Good evening to Dr. Fakana. We are from Team Byte, and we are the team that is doing the visualization for Peterson's algorithm. So my name is Nipowang Shilajaming, and my group members are Chong Siu-zhen, Chua Ki-yong, and also Tan Jingze. As for the task distribution part, we can see it here. So this is all our task distribution, and as you can see, everybody did their role, and we are doing our part. So let's move on to the product demo. So before the product demo, I need to show the flowchart for the design. So for what we are doing is we are trying to visualize Peterson's algorithm using a copy machine example scenario. And we are using Pygame, which is a library for Python, to build this. So I'll just show it a bit easier. Yeah. So this is our folder, and we just need to run Python simple Pygame. So how this game slash visualization works is that we have a coffee machine, and then there are two processors, or you can say two person, which is Alice and also Bob. So Alice and Bob are like we are trying to visualize a office setting where two-person wants to use a coffee machine. So how would they go about it to not uh, be collide or have like conflicts in using the coffee machine? So that's why we are trying to use Peterson's algorithm to not to avoid the conflict. So this is the flow chart of how this should work for Peterson's algorithm to avoid them accessing the critical section and also make them to achieve mutual exclusion. Okay, so this is how it works. So at first, so how this game works is that we can press the spacebar and it will step through us the process step by step. So let me press the spacebar. Okay, in step one, Alice wants to access the coffee machine, and at first, let me put it here. Okay. So at first, process Alice starts. Alice will set its flag to true, and then it will set the turn to 1, which is turn 1 is actually the turn of Bob, where the turn of Alice is 0. So after that, it will then check if the Bob's flag is true and if the turn is 1. So the turn is indeed 1, but Bob's flag is false as Bob hasn't started its process yet. So fortunately for Alice, she gets to not wait and get into the critical section immediately, which is accessing the coffee machine and making her own coffee. So we can see Alice is making her coffee, and in the next step, we can see that Bob's flag is turned to true, as we can see that Bob now is trying to start its process to make the coffee, but when it sets its flag to true and turn to 0, which is to Alice, but in the while loop, it detects that Alice's flag is true, and it's also the turn of 0. So it will keep looping in the while loop until one of the conditions is false. So unfortunately for Bob, he needs to wait for Alice to finish her process, her critical section first. And then for Alice, now she has finished making her coffee, and then she sets her flag to false. And this while loop will then detect that Alice's flag is already false, so we will let Bob know that he can stop waiting and access the coffee machine. So now we can see that Bob is able to make his own coffee using the coffee machine, and then when he's done using it, he will just set his flag to false, and then turn will still remain as 0. So this process will repeat and repeat, but mutual exclusion is always uh, mutual exclusion always stays, and conflict between the same two processes accessing the critical section is avoided. So that is all for the demo. Thank you for time and good doctor.
So now I'm going to present our code. Our code is going to visualize the Peterson algorithm with the Python and Byte. So you can see from here. Here is the some image that we have to visualize this algorithm, and this is the main code of our animation. So this kind of code is going to initialize and import everything needed to visualize everything. So this is the each step of the animation that we have to visualize. So we have a function here which is a draw step. So what is a draw step function? So draw step function is going to create a screen and like set the background color, and it is going to render the and display the everything of the code, and have a lot of if else function to visualize everything. So the main point is the handle step function. So the handle step function is going to handle the every step transition to visualize our Peterson algorithm. So for example, state init is equal to 0, and when the current state is equal to 0, then everything is initialized as false. Then when we click a space, then the current state will equal to Alice wants to enter. So when Alice wants to enter, the flag of Alice will be set to true, and the turn will be set to 1. And then Alice is in the waiting state now. So when Alice in the waiting state now, we Alice are going to enter the critical section. So our code is like this. If the flag 1 is false and turn equal to 1 is false, and it will be false, and and we not the false, then it will be the condition will be true. Then Alice will enter the critical section, which is using the coffee machine. So the state is updated now. So when we're going to next step is the Bob is going you want to also you want to use the coffee machine also. So then the next step is when Bob wants to enter the critical section, which is use the coffee machine. So the flag of Bob will be set to true, and the turn will be set to 0 again. So Bob is in the waiting state now. So Alice have to exit the critical section, which is he have to stop using the coffee machine. So the next step is the Alice exit the critical section, which is she stopped using the coffee machine. So the in critical section state is will be set to false, and the flag of the Alice will be set to false, and the current state will be set to mode is waiting state now. So it is repeated. It is same as the Alice and the critical section state also. So Bob is going to enter the critical section now. So after that, after Bob enter the critical section, and when Bob stop using the coffee machine, the flag will be of Bob will set to false, and it will be reset again. So this is a main loop. So this is a while loop that if keep repeating to use this to handle this function and also the draw step function. So the output should be like this. So here is the Alice state and here is a Bob state. So it's visualized very well and smoothly. Yeah, that's all. Thank you.